Perform an activity to investigate the relation between the total potential difference across combination of resistors in series and the potential difference across individual resistors. So they're asking us to look into that you have series connections and that each individual resistor has a potential difference across it. Obviously, only then the current will flow. So what they're telling is the sum of all of it, right? Whatever the resistance we have, read the voltage across all of it. Okay, the sum of each of this, the sum of all of it will be equal to the voltage across the ends. Ends is this. Again, read the question and try to understand. The total potential difference across combination of resistors means this. This is the total potential difference across combination of resistors, which are in series, as you can see, right? And the potential difference across individual resistor. These are the potential difference across individual resistor. So what they're telling is, if you look at each of this, if you take three resistors connected in series and supplied some with some voltage. So when you have a look at it, like example 3 volts, and here by default you will get 3 volts again, because 4 plus 3 plus 3 is 10, and at the ends we have 10 voltage across the ends. Again, basically this voltage should add up to individual voltage across the resistor. I'll explain the reason why this happens, but yeah, try to understand what is happening over here. So at the ends of the combination of resistor, the voltage across all of it is 10 volts. When we see the individual voltage reading, they'll add up to the voltage across whatever is there across all of it. Okay, so 4 plus 3 plus 3. So it's like there are 3 people, right? The amount they have, say one has 4 rupees, another has 3, another has 3. So in sum, what is the total? 10. Right? It's something like that. That's it. The voltage across each individual resistor, right? If you add them, it will be equal to the voltage across the ends. As simple as that. So you might be confusing as of now. So I'll show you an experiment to clear it up. So I have 3 resistors. As you can see, this is the experiment. I'm not able to zoom in. Actually, I can. So we have 1, 2, and 3. These are your 3 resistors. Actually, anyways, I should do it. 1, R1, R2, and R3. As you can see, there are one node, second node, and these are the ends. Is it not? So I have my voltmeter set. So as you can see, 20. So it will read a maximum of 20 volts, right? And I will check individually what are the voltage across each resistors and the combination. That is, at the ends, what is the voltage? So I have a constant supply of voltage. Actually, this is a positive terminal and this is a negative terminal voltage source. So what you have to do here is, not that, yeah. What we have to do here is, you guys have to note down each value. So when I take the voltage across the combination, I'll go with the combination first, that is this value, and then individually I'm measuring. So you guys have to note down that on a paper. Try to take an average. You won't get the exact value. Again, my connections and the device which I have, it's not that great. No, connections are okay. I think the device is not that great. And again, there are a lot of, it's not laboratory stuff, you know. Breadboard is also decent. Resistors are good. Voltmeter is not that great. And the voltage source is again handmade. So because of all of this reason, you won't get an approximate exact value, we'll get approximate value. Okay. So now again, please remember that you need to watch the video and note down the values as and when I change. Right? Please pause and note down. Okay. So that's the whole point of learning. Now you have to do the experiment and you need to observe, note, write down and come to a conclusion. That's the whole point of being a physicist. Okay, now you guys watch the video. So what was the first reading? It was around 5.44ish, is it not? The average was 5.40. The first resistor read around 1.66 volt, second read 0.16 volt, and the third read 3.56 volt. Right? So let's tabulate it off. This is 1.66, 0.16, 3.56, and this is 5.40. So what is the sum of V1 plus V2 and V3? The sum is 6, 6, 6, 18, 1 carry. This is 6, 12, 13, 1 carry, 4, 5, 5.38 volt. Right? And across the entire thing is what? 5.40 volt. So you can see both the values are approximately equal. So this sum is almost equal to the actual voltage across the ends. So this is what the whole experiment is about. Got it? That's it. So individually, when you add up the voltage, it will be equal to the total voltage that is supplied across the resistors. Okay. So in general, if you have a voltage of V across the ends of a combination of resistor and individually they have V1, V2, V3, right? And the total voltage will be equal to sum of the individual voltages. This is what you need to know. Now, so how do you write the answer? First, we'll begin with the apparatus, 3 resistors, voltmeter, battery key, and connecting wire. The circuit diagram looks the same. The procedure is make the connections, plug in the key. I don't have the key. Right now, I have the key. Note down the reading in each voltmeter. Fill this blank and note down the total voltage V also. We need to note down. So that is your observation. In conclusion, whatever the question asked, that is your conclusion, right? So this is your working and explanation for this particular question. Again, all of this is used for MCQ questions, 1-marker questions, and your numericals. So all of these points are important to understand and note. So please pause and have a running note for yourself.